Your LangGraph chatbot works perfectly in Dev, so you ship it. A user sends 3 messages, closes the tab, comes back an hour later, and asks, "What did I just ask you about?" The agent has no idea. The pod that handled the first turns was recycled, and even if it were not, your in-memory state evaporated the moment invoke returned. This is the moment every LangGraph developer discovers checkpointers. A compiled graph runs once and forgets everything, which is fine for demos and wrong for production. Real agents need 4 things, and all 4 come from one feature: multi-turn conversations where the third message sees turns 1 and 2. Resumability, so a mid-run restart does not lose the conversation. Time travel debugging, so when turn 17 breaks, you inspect turn 12 and rerun from there. And human in the loop pauses, where you stop, walk away, and resume hours later. Here is the one idea. A checkpointer is a durable store that saves the full graph state after every node, keyed by a thread ID. Because state lives outside the process, the graph can stop mid-run and resume later, even from a different process or pod. Let me walk the code because it is shorter than you expect. First beat, you add the checkpointer at compile time. You import MemorySaver, make 1, and pass app equals graph.compile with checkpointer equals it. MemorySaver is in process for tests. Swap in SqliteSaver or PostgresSaver for production, and the graph's behavior does not change, only where state ends up. Second beat, the thread ID, which is the whole multi-turn API. Every invocation now needs a config. Configurable, thread ID, some conversation key. Call invoke with a message and that config. Then call invoke again with a new message and the same config. And the second call sees the first call state. Same thread ID means same conversation. A different thread ID means a fresh one. That is it. No chat loop class, no session manager, just state keyed by thread. Third beat, inspecting and time travel. A compiled graph with a checkpointer exposes getState for the current snapshot and getState history for every checkpoint newest first. Each historical snapshot carries its own config with a checkpoint ID. So you grab an old one and re-invoke from it to branch. That is, Ryan from turn 12 with a different message. Fourth beat, streaming intermediate state. Where invoke runs to completion, stream yields each node's update as it happens, so your UI can show thinking, then searching docs, then drafting reply. Now bank a few production realities the lesson is firm about. Every node writes a checkpoint, so a tenured graph hitting a distant Postgres is 10 round trips. Pool connections and keep the database regional. Checkpoints hold the full state, so large documents or long histories balloon storage. Trim them. And thread IDs key all the state for a conversation, so generate them server-side with UID4 and bind them to the authenticated user, because a guessable thread ID lets one user read another's history. Persistence is a deployment detail, not a code detail. Change one argument and your demo agent becomes a durable, resumable one.